Hello and welcome, students. We are now going for the right now we are learning the chapter pair of straight lines. And in this chapter of pair of straight lines, we have done quite a lot. We are into the third exercise 4.3. And what we are doing here is, so far we have done pair of lines and all these. So we have done pair of lines, and so far in pair of lines, what we have noticed is that every pair of lines that we have studied in detail, those all pair of lines were passing through the origin. They all were passing through origin. You all saw that. See, we have studied such pair of lines. See, these two red lines, they are passing through origin. We have studied these kind of lines in detail. Look at these. Look at these yellow lines. They are also passing through origin. So this pair of lines. Okay. And don't go by color, please. Okay. Don't go by color, because see, if this one is L1, this is L2, this one is L3, this is L4. So you are not supposed to be saying that only L1, L2 is a pair of lines. You can have L1 with L3 also. L1, L3 is also a pair of lines. Okay. Yeah. You can have L2 with L3. You can have L2 with L4. Yes. So don't go by color. I'm just trying to explain it to you in a better way. So see, we have done a lot about such kind of pair of lines. We have done a lot about such types of pair of lines. But now see, students, it is not that you will have only such pair of lines. No, nothing like that. It's not that you will have only such pair of lines. You can have pair of lines which are not passing through origin. Yes, that is also true. This is y-axis, this is x-axis. Here you have origin. Okay. It's not always that we have pair of lines passing through origin. Okay, we understand that if the lines are passing through origin, they are some special kind of pair of lines. But see, these two pair of lines, they are not passing through origin. They are passing through they are intersecting each other at some distinct point, which is not origin, So say this point is, say, H comma K. The point of intersection of these two lines, that is, say, here I had written L1, L2, L3, L4. So this is L5 and L6. So L5 and L6, what is happening? These two lines are, see, these two lines are pair of lines and they are not passing through the origin. They are passing through H comma K. Okay. And see here, what I had written for this L1, L2, then here I had written L3 and L4. Okay. So see. Now, again, what I'm trying to tell you is, I want you all to be very focused. See here. Again, you don't go by colors. Don't go by colors. As I said that L1, L2 and L3 can be one pair of lines. As I said that L1 and L3 can be one pair of lines. So please understand that L4 and L6 can be a pair of lines. Yes, L4 and L6 can be a pair of lines. So if L4 and L6 is a pair of lines, again, what you are noticing that these two pair of lines are not passing through origin. You can check. See, L4. If I extend L4, so where is L4 intersecting L6? L4 is intersecting L6 at this point. At this point. Again, what you are noticing, see, this could be A comma B. So L4 and L6, L4 and L6, these two also is a pair of lines and they are not passing through. They are not meeting each other at origin. They are meeting each other at A comma B. It's a different thing. It's a different thing. See, you might say, sir, but L4 is passing through origin. That's okay. L4 is passing through origin, but L6 is not passing through origin. So when you are going to have the combined equation of L4 with L6, when you will have combined equation of L4 with L6, you will not have the homogeneous equation. You will not have the homogeneous second degree equation in X and Y. See, if I write the combined equation of L1 and L2, I will get the combined equation in the form ax square plus 2hxy plus by square equal to 0. A homogeneous second degree equation in X and Y. But when I'm writing the combined equation of L4 with L6, it won't be like this. No. L4, L6 combined equation won't be like this. L4, L5 combined equation won't be like that. L3 with L5, the combined equation won't be like this. Such an equation, which is a homogeneous second degree equation in X and Y, you get only when both the lines are passing through origin and or they are meeting each other at the origin. Okay. So what are we going to do now? We are going to write the combined equation of lines which are not passing through origin, So here, students, we are going for the combined equation of a pair of lines in general. That is, I'm going to derive the combined equation of pair of lines which may not pass through origin, So here you all see that we have two lines in the diagram. You can check L1 and L2 are two lines. Let equation of L1 be this and L2 be this. So the combined equation, we will multiply left hand side to left hand side and right hand side to right hand side. So right hand side being 0, when I'm multiplying, I'm getting 0. And in the left hand side, what I'm doing is I'm distributing product over sum. So this into this, then here this and this. So when this is getting multiplied, okay, you need to be careful while multiplying. So I distributed. So I got, see, I got this step, and this term. Okay. So next is now we are going to distribute from the right. So when I distribute, so here I will get a2x being multiplied with a1x, a2x with b1y, a2x with c1, and same thing with b2y. It will get multiplied with these three terms, and c2 also getting multiplied with these three terms. So when you multiply, this is as such, very simple steps. We had been doing such steps in lower standard also. So we are going to get such a big expression. Now see here, we are going to get the terms of x squared, terms of xy. Then we will also get the term of x. We will get the term of y squared. We will get the term of y, and we are going to get the term of constant also. Okay, now what you need to understand is, see, when you had the equation of lines passing through origin, remember, my dear students, you did not get the terms of x, y, and constant. Why? Because those equations did not have constant. Both the equations were passing through origin, so they were devoid of C1 and C2. So you did not get x, y, and constant terms. But here you are going to get x term, y term, and constant term. So I went for taking common C, A1, A2. There is just one term of x squared, so I wrote it. There are two terms of x, y. So I took x, y common, I got this. Then y square is single term, I wrote it. There are two terms of x, so I take x common. So I get this. Then there are two terms of y also. I take y common, I get this. I get a single term of constant C1, C2, which I wrote. Next. Now, after the students, we substitute few constants in order to make this equation look a proper equation. I'm writing A for this, I'm writing 2H for this, I'm writing B for this, I'm writing 2G for this, I'm writing 2F for this, and I'm writing C for this. Having done this, I get the final equation looking this way. So what is this? It is equation of, see, this is equation of pair of lines in general. It is the combined equation of pair of lines in general. This one is combined equation of pair of lines in general. Okay, so let's do this. Yeah. So see here, students, what I want to tell you is, if I have two lines, see, after this derivation, you should be able to understand that when we have two lines and the lines are in general, they are not specific lines. That is, they are not passing through origin. Okay, both of them. Okay, not both of them are passing through origin. One may or may not pass. Like, so here, when you have such an equation, then what is happening is the combined equation of such lines, is in the form, it is in the form, you are going to get ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Now, please understand that this part is extra part. And because of this, you were used to write the combined equation ax square plus 2hxy plus by square equal to 0. You were used to writing such an equation, which is the homogeneous equation of second degree in x and y. But this time, what is happening, students? You are not getting equation which is an homogeneous equation. The reason, you know it better. You know the reason why you are not getting a homogeneous equation. Now, secondly, listen, see here. You are not getting a homogeneous equation. You know the reason, because of the presence of this C1 and C2. Now, listen, students, I want you all to be very, very, very alert for this statement. Okay, everybody be alert for this statement. And then after that, I will ask you a question. You have to answer that question. See what I am saying. When I have two lines not passing through origin, then the combined equation of such two lines is a second degree equation in x and y. What is this? It is a second degree equation. It's a second degree equation in x and y. Okay. Now here something, when I made the statement, this equation is a second degree equation in x and y. When I made this equation, students, see, I did not say one very common word which we had been using too much, and that is homogeneous. I am not saying homogeneous second degree equation in x and y, because this is not homogeneous. And why this is not homogeneous, you know it better, because the aggregate power of individual terms are not same. See here, the power of this term is 2. If you check the power of x, then it is 2. Don't have to check the power of a. No. Why? Because we are not writing in x and y and a. No, you're writing only x and y. So you will check for x and y only. So see, the power of x is 2. The power of x plus y is 2. Then 2. But here it is not 2. See, this is x power is 1. This is also 1. This is 0. X and y power is 0. So here it is not a homogeneous equation. Okay, fine. So this you will write, please write. What you will write? You will write that when two lines are not passing through origin, their combined equation is in this form, which is a second degree equation in x and y. Yeah, now listen, students. See, just now we did a theory. In that, what I taught you was that when we have two lines passing through origin, then the combined equation, I'm sorry, I made a mistake. See, I told, we just derived a relation where we got that if there are two lines, they are not passing through origin. If there are two lines not passing through origin, then the combined equation of such two lines will come as second degree equation in x and y. Okay, it will come like this. Fine. But now here there is a catch. See, if you have two lines not passing through origin, then the combined equation will definitely be like this, a second degree equation in x and y. But remember, my dear students, if you are given some combined equation, which is a second degree equation in x and y, try to understand. If you are given some combined equation, which is a second degree equation in x and y, then you cannot just say that it will represent two lines. No, that is not always true. That you have to understand. Okay, if I'm having one such equation, which is a second degree equation in x and y, I cannot blindly say that this is two lines not passing through origin. No, such equation can be a parabola or an ellipse or an hyperbola also. Okay, yes, it can be or circle as well. This can even be a circle. So the condition for this to represent any such line, to represent pair of lines is, first of all, h square minus ab should be greater than equal to 0. Secondly, abc plus 2fgh minus af square minus bg square minus ch square should be equal to 0. So these condition needs to be satisfied. Okay. So let's start solving few problems on this. Yeah, students, look at this here, what they are saying. Look at this question. In this question number 2, I'm sorry, question number 3, it says, show that equation 2x square minus xy minus 3y square minus 6x plus 19y minus 20 equals to 0 represents a pair of lines. You have to show that this represents a pair of lines. See, they are not talking about pair of lines passing through origin, nothing. They are simply saying pair of lines. Why? Because it is clearly understood that, see, there is x term, y term. This is a non-homogeneous. This is not homogeneous. That's why this question arises. This question arise only because this equation which you have, it's a second degree equation in x and y. It is not a homogeneous second degree equation. Listen, my dear students, if we did not have these terms, if we did not have these terms, if we had directly equal to 0, then what would have happened? You understand? See, if this had been 0 directly, then in that case, this would have become a homogeneous second degree in x and y. And then there is no such question. Why? Because every homogeneous equations, which is second degree equation in x and y, represents two lines passing through origin. But here it is not the case. Here it is not the case. It is not a homogeneous. So what will happen? We will have to check. We will have to check whether it satisfies the condition. Okay. So let's go for it. See here. I will write here question number 3. I will start by writing the given combined equation is answer for this. The given second degree equation is the given second degree equation in x and y is what it is. It is 2x square minus xy minus 3y square equals 3y square minus 6x plus 19y. 2x square minus xy minus 3y square minus 6x plus 19y minus 20 equals to 0. Okay. Now see, I will write comparing with, now I will compare this with the general second degree equation in x and y. Comparing with, see, I will compare this with ax square plus 2hxy plus by square plus 2gx plus 2fy plus 2fy plus c equal to 0, right? This is second. And from after comparing, what I will do is I will get the value of a, b, c, h, g, h, all that I will get. Okay, so see here, I will get therefore, see, therefore a equals to 2. Now 2h is minus 1. See, 2h is minus 1. So h is equal to minus 1 by 2. See, 2h is minus 1. You see this? So 2h is minus 1. So you got hf. 2h is minus 1. H is minus 1 by 2. Then you have b equals to minus 3. Then you have, see, 2gx. And this is minus 6x. So 2g is minus 6. So g is equal to minus 3. And then 2f is 19. You see this 2f is 19. So F is equal to 19 by 2. And then what is C? C is equal to minus 20. C is equal to minus 20. Now I will write here. I will write here. Okay. C. I will get the value of h square minus ABC. First of all, h square minus AB should be greater than or equal to 0. So I write h square minus AB is equal to, find h square minus AB. H square, see this is h. So minus 1 by 2 square, h square minus AB. A, what is A? 2. A is 2. B is minus 3. B is minus 3. So what I got? I got 1 by 4 plus 6. You see this 1 by 4 plus 6. So this is 24, 25 by 4. We are getting 25 by 4. Okay. And therefore, what I see that h square minus AB. See, I write therefore h square minus AB is greater than 0. See, h square minus AB should be either greater than 0 or equal to 0. Okay, so the first condition is satisfied. Okay, now I go for the second condition. What is second condition, students? See, the second condition is I will find out ABC plus 2FGH minus AF square minus BG square minus CH square equals to 0. This should be equal to 0. Got that? So I will find out this value and it should be 0. Now see, there is a trick to remember this. There is a trick to remember this expression. I will tell you that trick. Okay. See, what is the trick that I will now tell you. First, let me draw the line of demarcation. Okay, so here I go for, see, the trick is, it goes as follows. Do you know the English alphabets? Yes. What are they? See, the English alphabets are, it will start with A, B, C, D, E, F, G, H, right? A, B, C, D, E, F, G, H. Okay, fine. And so on. We are not interested. We are interested only up to H. So see here, write the first three. So it is what? A, B, C. And they are all multiplied. Then don't write 2. Don't write this and this. You're not writing 2 letters. So that's why you are writing 2. You write number 2. Why? Because you're not writing 2 letters. And then write the next 3. So A, B, C plus 2FGH. Then write minus and take A from here and square of this. So AF square minus. Take B from here and square of the second. BG square, and take C from here and square of this. So minus CH square. They all are negative. And this should be equal to 0. The value of this should be equal to 0. So what I will do? I will calculate its value. I will calculate its value and check whether it is coming 0. So see, I will calculate ABC, A into B into C, 2 into minus 3 into A is 2, B is minus 3, and C is minus 20. Okay, ABC plus 2FGH, 2 into F. What is F? F is 19 by 2. F, G. What is G? G is minus 3. And H, what is H? H is minus 1 by 2. 2FGH minus AF square. A is 2. F square. What is F? F is 19 by 2 square minus BG square. What is B? Negative 3. Minus of negative 3. See, after minus, I have negative 3. So I'm putting that in a bracket. So BG square minus G square. What is G? G is minus 3 square minus BG square minus CH square. What is C? C is minus 20. So minus of minus 20, CH square. What is H? H is minus half. So minus 1 by 2 square. Now I go for the simplification. So I get here what? See, this is 60 into 2. So 120. Okay, minus minus plus. Okay, 620. Then now see, this 2 and this 2 will cancel. What I get? Plus. See, minus minus plus. This is 57 by 2. 57 by 2. Okay. 19 threes are 57. Okay, then minus Okay, see, this is 19. See, 2 into 19 square is 381 upon 4. See this? What are you getting? 2 into 381. So see, this is minus 2 into 381 upon 4. Okay? Yes, sir. Then minus. See, this is minus this one. And then this is minus. So plus 3 into 9. Go slow. See, this is plus 3 and this is 9. Okay, minus 3 square is 9. Then next. See, minus minus plus. So this is plus 20, and this is into 1 by 4. So 20 and this is 1 by 4. Now, so see the next step. The next step is, everybody watch. The next step goes as follows. What you have equal to 120 plus 57 by 2, 120 plus 57 by 2 minus 381 by 2. See, this is 2, this is 4, plus 27 plus 27 plus 5. Okay, this is 4 ones are 4, 4 fives are 20, 4 ones are 4, and 4 fives are 20. Got that? Okay. So now, see, look at this. So this is, see, this is the common denominator. So 120 plus 32. See, this is 120 and this is 32. So 152. 120 plus 32 is 152. So this is 152. And then here what you have, you have plus 57 minus 381 upon 2. So just subtract 57 from 381 and then put the sign of minus because 381 is bigger number. So what is 11 minus 7? 4. 11 minus 7 is 4. This is 2. Okay. And then here you have 7. So 2 and this is 324 minus 324. So you got here. So you got 152 plus minus 324 by 2. Okay. So this is 152. Plus of minus is minus. 3 ones are 3. 3 ones are 3. Then this is 6. I made a mistake or what? 32. Somewhere I'm committing a mistake, it seems. Wait. Yeah, students, see, I committed a mistake. I wrote the square of 19 as 381. I'm so sorry for this. It is 361. 361. Okay. So here also this is okay. That's possible, sometimes it does happen. It does happen sometimes. I'm sorry. So this is 361. 361, this is also 361. Now see, so this is 4, and here what do you get? You get here 0. Because see, 1 is borrowed, so this is 5, 0 and 3. So now 304. So this is 1, 5 and 2. What is 152 minus 152? 0. Okay, so since 152 minus 152 is 0, what will you write next? After that, you will write here. See, here comes the next step. So the next step you write that, therefore, you will write therefore ABC plus 2FGH minus AF square minus BG square minus CH square is 0. Okay, this is, see, this is 1, this is 2. Therefore, from 1 and 2, therefore from 1 and 2, 1 and 2, we can say that we can say that given equation represents a pair of lines. So see, what's the flow of the solution? You have to write this, then you have to write this, then you have to write this, and then this. Come on, do it fast.